Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. These are some exercises about section 9.2, inconsistent and dependent systems. So here we ask it to use Gaussian elimination to find the complete solution to each system of equations or show that none exists. So as usual, to use Gaussian elimination, we start by writing the augmented matrix of the system. Coefficients of x, coefficients of y, coefficients of z, and then the constant terms. We need this number to be 1, so I will interchange row 1 with row 3. Row 2 will remain the same, and row 1 would be here. And now I have 1 in the first row, first column. So I use it to make zeros below. So negative 2R1 plus R2 and negative 5R1 plus R3. The first row remains unchanged. And let us now write the new row 2. Negative 2 plus 2 is 0. Negative 4 plus 5 is 1. 6 plus 2 is 8. Negative 10 plus minus 1 is negative 11. Row 3 also would be changed to 0. Negative 10 plus 12, that's 2. 15 plus 1, that's 16. And negative 25, 5 times 5, 25 plus 10, that's negative 15. I need this number to be 1. It is already 1, so I use it to make the number below 0. Row 1 and row 2 remains unchanged here. And now row 3 would be changed. 2. Negative 2 plus 2, that's 0. Negative 16 plus 16, that's 0. Negative 2 times 11, that negative 11, that's 22. Minus 15, that's 7. So I have 0 equals to 7. This is impossible. So the solution set is phi, and there is no solution for this system. The system is inconsistent. Another exercise. Again, I will interchange row 1 with row 3 because I need 1 in the first row, first column. According to Gaussian elimination method, if you don't know Gaussian elimination method, please check section 9.1 lecture. Row 2 as it is, and row 1 will become in the position of row 3. All right. Now I use this one to make 3 and 5 zeros. It's a systematic way, if you understand it. It's a very easy way and systematic way. 1, 2, negative 2, 3, row 1 unchanged. Negative 3 plus 3 is 0. Negative 6 plus 4, that's negative 2. Negative 3 times negative 2 is 6 minus 2, that's 4. Negative 9 plus 8, that's negative 1. Negative 5 plus 5, that's 0. Negative 10 plus 8, that's negative 2. 10 plus minus 6 is 4. And negative 15 plus 14 is negative 1. It's clear here that we will have infinitely many solutions. But to write it in the Gaussian elimination method form, in the row echelon form, we need negative 2 to be 1. So I divide R2 by negative 2. 4 over negative 2, negative 1 over negative 2, and row 3 as it is. And now I make this negative 2 0 by multiplying row 2 by 2 and add the answer to row 3 and replace row 3 by the answer. This is negative 2. Well, 2 plus negative 2 is 0. Negative 4 plus 4 is 0. 2 times half is 1 minus 1 is 0. So the first equation is x plus 2y minus 2z equals to 3. The second equation, y minus 2z equals half. And the third equation is 0 equals to 0. We solve the second equation for y. So this is the y coordinates. And now in the first equation, we replace y by its value. And we solve this equation for x. 2 times 2z is 4z. 2 times half is 1. Now 4z minus 2z is 2z, and when you take it to the other side, it would be negative 2z. And 3 minus 1 is 2. And this is the value of x. So the solution set of this system would be x is negative 2z plus 2, and y is 2z plus half, and z is z. And you can write that z belongs to R. You can write it like this or outside. All are okay. So here we have infinitely many solutions. Gaussian augmented matrix. I have to interchange row 1 with row 3 because I need 1 in the first row, first column. I use the 1 in row 1 to make 4 and 3 zeros. Negative 4 plus 4 is 0. Negative 4 plus minus 2 is negative 6. 4 plus minus 8 is negative 4. Negative 12 plus minus 4 is negative 16. Negative 3 plus 3 is 0. Negative 3 plus 4 is 1. 3 plus 2 is 5. Negative 9 plus 3 is negative 6. Now I need 1 instead of negative 6, and I have 1 below. So I will interchange row 2 with row 3. You can divide by negative 6 to get 1, but you will have fractions, and I don't like fractions. So now I use the 1 here in the second row, second column, to make the -6 0. Six minus 6 is 0. 6 times 5 is 30. Minus 4, that's 26. 6 times -6, that's -36. Minus 16, that's -52. These are large numbers, but 26 and 52, that's nice. Now I have to make 26 1, so I will divide row 3 by 26. It seems that this system has a unique solution. -52 over 26 is just -2. So I can, now I reached the row echelon form, so I can write the equations. And actually we have here a unique solution. We have the value of z, back substitution. We put it in the second equation. This is -10. If you take it to the other side, it would be 10. 10 minus 6 is 4. This is the value of y. Put the value of y and the value of z in the first equation. Y is 4. Z is -2, so negative z would be +2. 4 plus 2 is 6. Take it to the other side. 3 minus 6 is -3. So the solution set is the triple. X, the order triple, -3. Y4, Z, -2. This is the solution of the system. You can pause the video and try to solve this equation by yourself. You need a lot of concentration, and it's a practice to be accurate in your answers in each step. Well, what should I do? I will multiply row 2 by -1 and take it to the first row. Okay, so negative R2 by -1, then R1 with R2 interchange. So I will have 1, 4, -2, -3. This is negative row 2. I will have it in the first row, and the first row will be in the second row. Now I have 1 in row 1, column 1. I use it to make zeros below. So negative R1, -8 R1 plus R2, and -2 R1 plus R3. You just memorize the method, the steps, and you do it. But you practice to be accurate. So -8 plus 8 is 0. -8 times 4, and you can use the calculator whenever you need. -8 times 4 is -32 plus 5, that's -27. -8 times -2, that's 16 plus 11, that's 27. -8 times -3, that's 24 plus 30, that's 54. The numbers are large, but you see 27 and 54, nice numbers. Now -2 plus 2 is 0. -8 plus -1 is -9. 4 plus 5 is 9. 6 plus 12 is 18. This tells me that I didn't do anything wrong. The numbers are excellent. I will divide row 2 by negative 27 to have 1 in row 2, column 2. And it's clear to me now that this system has infinitely many solutions because of row 2 and row 3. So when I divide by negative 27, I'll have 1 here, negative 1 here, and negative 2 here. Divided by negative 27 is just negative 2. And now I use this one to make the negative 9 0. So 9R2 plus R3. 9 minus 9 is 0, negative 9 plus 9 is 0, negative 18 plus 18 is 0, and we have infinitely many solutions. So x plus 4y minus 2z, we write the equations, and y minus z equals negative 2, and 0 equals to 0. The second equation, I solve it for y, and then from the first equation, I replace y by z minus 2, and I solve it for x. So x plus 4z minus 8 minus 2z equals negative 3. 4z minus 2z is 2z. When I take it to the other side, it would be negative 2z. And negative 3 plus 8 is 5. So this is x. So the solution set would be the x coordinate, the y coordinate, the z coordinate, and z is any real number. So this is the solution of this question. Here we have 2 equations and 3 variables. So definitely we will have infinitely many solutions. Well, I need 2 to be 1, so I will divide by 2. I have no other choice here. 2 divided by 2 is 1. Now negative 3R1 plus R3 plus R2 to make the 3 in row 2 0. Negative 3 plus 3 is 0. Negative 3 over 2 plus 6 over 2 would be 3 over 2. Please use the calculator. 3 over 2 minus 4 over 2 is negative half. Negative 3 plus 3 is 0. All right. Now I need 3 over 2 to be 1. How to make 3 over 2 1? Multiply by 2 over 3. When you multiply 2 over 3 times 3 over 2, you get 1. So this is 1. Negative half times 2 over 3 is negative 1 over 3, and this is 0. So now finished. I cannot do anything more using Gaussian elimination. If you are solving using Gauss and Jordan, you can use this one to make the half 0 if you like. But it's okay. X plus half y minus half z equals to 1. And y minus 1 over 3z is equal to 0. Solving the second equation for y is 1 over 3z. Let us solve the first equation for x. Half times 1 over 3. Z minus half Z equals 1. So I have x plus 1 over 6 Z minus half Z. Well, 1 over 6 minus half is negative 1 over 3. Equals 1. So x in fact is 1 over 3z plus 1. And the solution set would consist of all the ordered triples in the form 1 over 3z plus 1. And what is y? 1 over 3z, and z is z for any real number z, or z could be any real number. You can pause the video and solve. Let me start by the augmented matrix. Well, this is a nice augmented matrix. Well, it seems everything here is fine. There is no need to find if you write the augmented matrix, you will see that it is already written in the row echelon form. So I immediately from the second equation find y, 5z, and I immediately put the value of y in the first equation. And 10z plus 3z is 13. And when you take it to the other side, it's negative 13. So the solution would be negative 13z plus 5. Or if you want, you can take zt and write it negative 13t plus 5. And y is 5t, and z is t, and t is any real number. So this was an easy question. Write the augmented matrix 1, 3, 1, negative 1, negative 2, negative 6, 2, and negative 7. This is one that's nice. Use it to make the 3 0 in R2. Negative 3 plus 3 is 0. Negative 3 times 1 is negative 3 plus negative 1, negative 4. Negative 3 plus negative 1 is negative 4. Negative 3 times negative 2 is 6 minus 6 is 0. Negative 3 times 2, negative 7 minus 7, that's negative 13. Now this negative 4 has to be 1. So I divide row 2 by negative 4. So I'll have 1 here and 13 over 4 here. Now what do we get from here? If we write the equations, x plus y minus 2z is 2, and the second equation gives us y equals 13 over 4. So we have the value of y, and if we put it in the equation x plus 13 over 4 minus 2z equals 2, then x would be 2z when you take it to the other side, and 2 minus 13 over 4. 2 minus 13 over 4 is just negative 5 over 4. So the solution set would be the value of the x coordinate 2z minus 5 over 4, and y is always 13 over 4, it's fixed. And I can take zt if you like, so this is t, and z is t, and t could be any real number. So we have infinitely many solutions. This was the last exercise. Hopefully you enjoyed solving linear systems.